Hey, as an extension to what we've already studied and covered so far, I'm gonna just throw some examples at you and trying to get you to be familiar in converting from formulas to names and names to formulas. Alright, and then later on in this video, I'm going to extend this to the high level students in terms of drawing the diagrammic representation of these examples, or in a format known as Lewis structures. So here we go, let's get started with this. What we have here is K2SO4. And the first thing you need to do is identify the cations and anions in this formula. Right away you should know that cations are usually written before the anions, alright? And so what we have here is we know that this is going to be the cation. And what is this cation? The symbol is K. Look it up in your periodic table, and it so happens to be potassium. Alright? And if that is the cation, then the rest must be anions. And this anion here is a polyatomic anion. Alright? If you look at it on a periodic table, you would determine as like, well, it's sulfur oxygen or potassium sulfur oxide. That does not exist. Right? Because it's just too long of a name for you, and it's a bit of a tongue twister. So you have to be able to identify that it's a polyatomic anion. And what is a polyatomic anion? Well, by looking at the list or remembering the list that are provided to you, you know that it is sulfate. And so the name of this formula is potassium sulfate. There you go. Okay? Now, what about the next one? Well, next one here is the cation, again you identified, is Fe, which is iron. Now, here comes the tricky part. How do you know, because iron has multiple valencies, how do you know the charge of this ion? Well, let's look at the anion for clues, okay? The anion here is oxide. Oxide, you know, has a -2 charge. And so the charge of this ion must be 2 plus. And how do I know that? Well, we know that the compound here has to be electrically neutral. That means the charges will have to balance out or cancel out. Alright? And by looking at the formula, you can determine that there is one oxide and there is one ion. So if the oxide has a -2 charge, 2 minus charge, that means the ion must have a 2 plus charge. So I have determined that the ion is ion 2 plus. So it must be ion 2, and the anion is oxide. The anion is oxide. So the name of the compound is iron 2 oxide. The third one, we have Al, and then with the parentheses or brackets 3. And so what we can determine is that this must be the cation. This must be the cation. And this will be the polyatomic anion. Now, the reason why there's a bracket written around the OH is because OH is the polyatomic ion. What is OH? It's hydroxide. We know that now. All right. So how many hydroxide does it need to neutralize a 3 plus aluminum? Well, aluminum is 3 plus, hydroxide has 1 minus or -1. So you need 3 hydroxides to neutralize or balance out the charges of aluminum. And so to represent that you have 3 hydroxides, you draw the bracket around there and the subscript at the bottom right corner. Okay? So we know that this is aluminum. and the polyatomic anion must be hydroxide. So the name of the compound will be aluminum hydroxide. Now we have a name that we're going to convert to formulas. Okay, so how do we do this now? Lower the cam. We have copper 1 oxide. So first we need to write the symbols, the formula symbols for copper 1. Right? So copper is Cu, and because this is the charge that's given to us, we know it's a plus. Oxide, we know, is a 2 minus. And so what would the formula be? Well, again, we can do the drop and swap technique, right? We'll put 2 here, and we'll put 1 over there, and what you will get is Cu2O. And that will be the formula for copper 1 oxide. What about this one? Lead 2 nitrate. Well, lead 2, now we know the charge for lead, okay, so it's lead Pb2 plus, that's lead, and nitrate, from our list that we've remembered, has this formula NaO3 minus, okay, and so when we do the drop and swap, we take the coefficients and we're going to drop them. We notice that you need 2 nitrates for every 1 lead 2 ion. And so the formula would be Pb, and because you need 2 nitrates, you have to write the brackets. And you write the nitrate inside those brackets. And because you have 2 nitrates, you write the 2 at the bottom right corner here, like so. And so what you get here is now the formula for lead 2 nitrate. Finally, we have sodium dichromate 6. Sodium, we know it's Na plus, and dichromate is from the list that I've given to you guys. The Cr2O7, 2 minus. The charge here is 2. Sodium has a charge of 1. And so you need 2 sodiums for every dichromate ion. Or you can do the drop and swap. Alright? So you need 2 sodiums ions. And the chromate. The dichromate ion will be written down like so. And so this will be the name of your the formula of sodium dichromate 6. Alright. Now if you're an advanced learner and you want to learn the how to draw the Lewis diagrams for these elements, stay on. Otherwise you may shut off. Okay. Now let's talk about potassium sulfate. We know that there are 2 potassium ions, so we will represent the ions in brackets or square brackets, and the symbol in here like that, and because it's a +1 charge, we write 2 of them. And there's 2 potassium to balance off with 1 sulfate. So we have 2K, and we have the sulfate, which we will write as SO4, and the charge of the sulfate is 2 minus. Now we don't really need to draw the valence electrons because it is more complicated than the simple binary ionic compounds that we've learned previously. So that's just how you would do it. Very simple. What about iron? Iron 2 oxide. Well, iron, you represent it as a 2 plus, and oxide, you represent it as 2 minus. Now because this is a monatomic anion, you can write in the valence electrons. Aluminum hydroxide, again we have 1 aluminum. We have 1 aluminum with a 3 plus, and we have 3 hydroxides and each hydroxide has a negative 1 charge, and so I'll represent it here. Quite easy, isn't it? Copper 2, so you need 2 coppers. Copper 1 oxide, so you need 2 coppers, ions, copper plus ions, and you have 1 oxide, because this is a monatomic. Feel free to put in those valence electrons. Lead 2 nitrate. You have 1 lead ion with a 2 plus charge, and you have 2 nitrates. And you got to write the charge, just because you want people to know the charge of nitrate. And finally, we have sodium dichromate, 6. Okay, you have how many sodiums do you got? 2 sodiums. Whoops. 2 sodium ions, and we represent it like that. And 1 dichromate, 6. Dichromate 6 has 2 negative charge. And that's it. This is how you draw the Lewis diagram. That's how you do the Lewis diagram.